I'm going to demo UCAN authorized retrievals now. I just got this working, so super excited. This is how you create a new retrieval server. So UCAN authorized retrieval server. It's very similar to just a regular UCANTO server. The only difference really is that your invocation handler gets an extra parameter, which is the request, and it also allows you to return an additional value. Whoa, which is a response. So here we're creating a new retrieval server. We've defined a capability called content serve. So I can click through to this. You can see it's just a new, just a capability. And the where is it? There we go. Where is the test? Where is the test? Here we go. There we go. Back to where we were. Yeah, the handler for this, the handler function, all it does is it prints out the delegation once it's got it, or the invocation. It tells you that it's handling this. It prints out some information from the request. If you need that information, you can get hold of the URL and any HTTP headers that were sent. And then it just looks at the invocation, figures out if it's it basically gets the range, the byte range that it wants to be served, or that is being requested to be served. And then constructs the response with the partial content HTTP status. We've got some headers, the content length, but also the content range that is being served. And then all we do is we've created some data, some random bytes up here, like 512 of them, and then we sort of slice off the start and end from the requested range. And then return that. So what actually happens is the UCAN invocation comes in HTTP headers. It's just a HTTP GET request, and the response receipt goes back in HTTP headers, but the actual data goes back in the response body. So that's the whole idea here, is that we can just make a GET request with a special header and get a response that is the actual data that we want to receive. So that's pretty cool. You don't have to do 2 requests. You don't have to post to get some data and then go and get it separately. You can just do it all in one, which is great. And the cool thing about this, right, is that if your invocation, your content serve invocation is too big to fit in HTTP headers, then the client will automatically split it into multiple requests. And it will send the invocation, like if it's too big, it will send the invocation block, and then the server will have to respond and say, I don't have all of the proofs. Like I can't execute this. I don't have any proofs for this. These are the proofs you need to provide. And you get back a list of proofs that you need to give. So you send another request with the same invocation. You don't have to send the invocation again. You can just send the SID of the invocation. But you would then send a new agent message with the proof that you were missing before. And you keep going until the server has cached all of the proofs that it needs to execute the invocation. So here we're just exposing the UCAN server as a HTTP server, which is kind of what you need. And then what we do later in the test here is create a new connection. We're just basically going to call the service. We've got a URL for the service, URL for this specific blob that we're constructing, and then we're actually creating an invocation. This is the thing that will go in the HTTP headers. We're saying we want this blob data, but we want the content range 100 to bytes 100 to 200. So this sends the invocation, and this is the kind of bit that's a little bit different. When you execute an invocation now, you get back a execution response, but you also get back a HTTP response. So execution response is as as before. It's just the receipt for the invocation that you construct, and this is pretty much similar to what you'd normally do anyway, but the difference is the HTTP response. So this means that you can not only get hold of the receipt, and so what we're doing here is just getting the receipt, making sure it wasn't a an error, and just checking that in the receipt we received the same information as we sent in the invocation, essentially. But then this is where we can use the HTTP response, and we can get back the data by reading all of the HTTP response, and then we just check that the actual data, the actual body data we received is in fact the same as the data if we slice it ourselves. So let's see this in action. So we can run go test. There's a few tests, but there's one of them which actually creates a delegation chain that is like 10 delegations long. So it's super long. You can see it there. I'm going to just scroll all the way to the top. Where are we? Up here. Here we go. Right. So this is right at the start here. I'm going to explain what all of these log lines are. So this is a partitioned retrieval request. It's got a proof chain of 10 delegations. So what happens here is we send a GET request to this URL. We send, so this is just printing out the HTTP headers we sent in that GET request. And we sent an X agent message here, which is really long, right? And actually, this is actually gzip, so it's shorter than it would be otherwise, but that's 2.6 kilobytes, and the server is configured to reject any headers that are more than 2K. So it got back a 431 response, which is a special HTTP status that says that your header fields were too big. So the client has automatically sent another request to the same URL. And so it's doing the same. So we're printing out the same information again here, and we got accept encoding user agent again. But look, this X agent message field is now significantly shorter than it was before, because what's happened here is it's looked at the agent message and said, okay, well, I'm going to split this up into multiple agent messages. So this one will have the invocation in it, but none of the proofs, and the next one will have the SID of the invocation and one of the proofs, and the next one will have the SID of the invocation and another proof. But yeah, you'll see we've got, so yeah, our headers here are 775 bytes. You can see that we've got like this idea of a delegation cache on the server. So we missed on this particular SID. This is probably a SID of a proof, but we did get I'm guessing this is going to be the cache put was the SID of the invocation, which is just a delegation in and of itself. But yeah, what happens here now is instead of saying your request fields are too large, we send back a 510 error, which 510's HTTP status is a known status code. It's called not extended. It means that there's you need to provide some more, in this case, more proofs. We've got a UCAN cache expiry field, which tells you when the cached data is going to expire. And you can see in our body here, it says proofs were missing. Resubmit the invocation with the requested proofs, and the proofs here is this. We want a proof that ends in BGGE. So here comes another request, another GET request. We've got another agent message. And you see that we got a cache hit for the original invocation. We just put that back in the previous request. We got a cache miss for another proof, but we've put that requested proof. So you can see that this agent message here actually included the requested proof from the previous request. So we've put that in the cache, but we've missed another proof. So again, we get a 510 not extended with proofs we're missing. This is the one Mr. KE as a proof that needs to be provided. So we get a cache hit on the original, we get a cache hit on the GGE one, we get a cache miss on another one, and we get a cache put on the Mr. KE. And so this kind of continues on and on until we keep going. Like you can see, we get loads of cache hits. So this is a pretty extreme example. But eventually we get to a point where we've actually got all of the proofs that we need in order to execute the invocation, and here it is. So this is this bit here is actually the first time our handler has been invoked, because now it has all of the proofs. It can the UCAN server can validate that the invocation is legit, and so it will call our handler, and then we can respond with the actual data. So what our handler does, if you remember from the test, was it just prints out the delegation here, tells you that it's handling this, and so you can see the actual delegation is insane. It's just got this massive chain of proofs. So this is the actual invocation up here with the particular byte ranges that we wanted to receive. These are the delegations all the way from the root, the server, which is the server will be this Z2Z, I think. But yeah, when the invocation is done, we get back our 206 partial content. We get back a receipt in the agent message. We get back our content length. We get 101 bytes, and we get a content range for the bytes that were served of 512. We know it was the data was some random data that was 512, and that's it. The invocation succeeded, even though we had to do multiple requests to kind of queue up all of the proofs in the server. That's all I wanted to show. Isn't that awesome? Pretty cool.